Welcome to Nutrifier for CS6440 Intro to Health Informatics. Our mentor's been Johnny Bender from Health and Human Services. Our advisor's been Megan Harrison. TA mentor Taylor Starton. We are Team 57 Henry. We have Alex Tugman as a developer, Carolyn Wine as designer and analyst, Felipe Goste as a developer, Henry Abbey as QA and tester, Justin Lewis as developer, and I'm Paul Davis as the PM and designer. Our goal has been to support the roles of dietitians and healthcare providers, integrate nutrition information and food environment information into healthcare, and to benefit clinicians through FHIR data and interactive tools. We've successfully created persona role views, been able to visualize summarizing the data, and achieve data integration with Cerner and HDAP. We've simulated through synthetic data the food environment, MyFitnessPal, and HEI scores. On the application, we've rewritten the application to be a dynamic user interface and added 7 additional screens. We've also achieved modular design and deployment through React, Mongo, and Docker. We've implemented all of our tasks to design, build, and deploy a functional system on Cerner. We have deployed it with some mock-up data and synthetic data where data was not available. We performed research on benefit to the users and the viability of the product. We performed research on fitness and food data APIs and also conducted interviews with registered dietitians. In addition, 19 high-fidelity prototypes were built, which will greatly benefit future work.
This semester, we focused our usability and design efforts on finding the right data to add to our application. This meant several meetings with our advisor as well as industry experts and some reviews of available APIs. This gave us valuable feedback in updating our color coding on the observation graphs to industry standard, as well as adding a toggle switch to create a summary view for our users. Our user feedback also told us that many medical applications are too busy, and therefore we simplified our layout to make things easier for the user to discover.
The current state of Nutrifier is a significant improvement of the original. Apart from meeting all the functional and system requirements for spring 2019, we also completely redesigned the front and back ends of the system. We leveraged some useful user-centered design principles to increase the system's performance and affordance to the user.
Deployment. The application consists of 4 Docker services. The frontend, which encompasses the user interface and FHIR integration. The backend, which integrates local and external data sources and pre-processed data for use by the frontend. The REST API framework, which allows data flow to and from the local database. And the database itself, which stores synthetic data to mimic external APIs and potentially user information across sessions. The application is deployable on Cerner, HDAP, and GitHub pages, allowing for a wide range of use cases. These services work together to provide valuable information to the user. When a patient is selected in the front end, food purchasing data is obtained by the backend from the database via the REST API. These food items are then assigned nutritional value by querying an external USDA API. A final healthy eating index is assigned to the food items, and this information is provided to the front end for visualization and provider usage.
Let's talk about our innovations. The first is data availability. The novel idea in this app is displaying a patient's dietary information alongside their medical. Taking that nutritional data and reaching out to public API sources, such as the USDA database, can allow a provider to see a much more complete picture of a patient's health. Next is performance improvements. Converting the app to run as a static page and some improvements in libraries used really reduce the load that the page requires to run. Loading times and data usage was significantly reduced. This is very important for patients or providers with limited or metered data. And finally, the user interface was updated with a very modern card-based designs that uses the latest UX principles.
To launch the application, we go to the Cerner development portal and we can select a patient. And this should give us an access role restricted to retrieving information specifically for this patient. So when the application loads up, you can see the patient's name at the top, demographics, more information about the patient. We have food allergies, drug allergies, and observations. And down at the very bottom, we can see the observations over time. Loading up one of these, you can mouse over some of the data points to see more information about the observation. And then down here at the bottom, we have the link code, and it will open up a new tab to give more information about this specific observation. So I'm going to load up another patient that has a little bit more data. When we go to the medications tab, you can see that some of the data here is missing, and this is just because of the data that we're getting back from the Fire server from Cerner. Scrolling down, you can see, much like the observations, that we have an RxNav tab over here. We can click this link and it will give us more information about the medication that the patient is taking. Moving on, we have the procedures tab that would show a little bit more context about the procedures that the patient has had. In addition, we have the clinical notes tab that would show more information about notes that were taken on the patient. And then we have the diet tab. So this application, Nutrifier, revolves around bringing diet information to the electronic health record. Many of the tabs I've shown so far have been more medical data related. This tab shows more information regarding diet and eating habits of the patient. On this page, we see the healthy eating index over a few months. The MyFitnessPal tab is currently preloaded with synthetic data. Future goals for this application include allowing patients to sync their account with MyFitnessPal so we can query their eating habits and display it here. The next tab shows the food insecurity survey. This was implemented with Survey.js, and we can publish these results to the database to collect them. So at the bottom, you can see how the data would be published. And then lastly, we have the shopping list here. This is currently querying our backend database, and we're able to query UPC codes that are entered by the patient and populate this table to show the shopping habits of the patient. Lastly, we have the environment tab, and this tab shows how we can use a survey with a map in order to be able to collect data about the patient and store it in our database. So this project was an existing project that had a front end and a back end server that was worked on by students in previous courses. When trying to set up and make changes to the code, we found the existing code base wasn't very modular and making it difficult to maintain or add on to. The customer agreed to our request to replace the front end, and we proceeded to rewrite the entire front end. This slide shows an example of some of the existing code. This is taken from the medication page where the team was drawing SVG images onto a graph. A small part of the application, I felt drawing processes like this should be managed by JavaScript dependency packages that could be imported into the project. Quite a few hours were invested into trying to understand the existing code base. We decided to time box rewriting the portal in React. The initial demo was successful, and we proceeded with creating a whole new front end. As a result, the code is now easier to follow. It utilizes class objects and React components for many of the files within the code package. It also uses maintain JavaScript packages to conduct the rendering of our metrics and tables. The code was organized in a manner such that locating certain aspects in the code is much easier. The application can also be built into a single page hosted out of a flat file like an S3 bucket. A few key points in the new front end is that we rolled our own authentication scheme. There exist a few authentication packages for Smart on Fire, but they didn't satisfy the needs of our application. Our application is designed to be launched from a centralized server with a scope policy specifically to one patient. One of the highlights of migrating the code base to a new framework is that we saw a significant performance increase. We use Lighthouse within the audit tab of Google Chrome in order to be able to conduct performance tests. This slide shows the Lighthouse performance score of our loading page. Our performance metric was given a score of 99 compared to the OLUI's performance score of 88. To summarize the performance increase of the initial program load, comparing the old UI to the new UI, we saw an over 80% reduction in the number of network requests, network payload, and page load time.